All right, welcome back, everybody. We're going to finish up the first section. The first section dealt with introduction to graphing. We first started off with a graph. And we had 2 points. Once you have 2 points, you can connect them, and that creates a line that goes on forever both ways. And I asked you all, what can we do if we have 2 points? What can we find with that information? Slope, distance, equation of the line, which I'm simply going to call EOL from now on, and midpoint. And as an added bonus, we're going to use this information to define circles. We're going to go from a straight line to define circles. The first one we talked about. The change of y, the vertical change over the change of x. The variable symbol we use to represent slope is little m. And that's our formula. That's how we represent it in mathematics. Where the change in y and the change of x, change simply means the difference between two numbers. The change simply means the difference. By difference, we always take the second number minus the first number because it's always going to be positive. We're given 2 points. We have point 1 and point 2. Each point is made up of what's called an ordered pair, x and y component. To differentiate, to distinguish between the 2 bits of information, we put these subscripts. The x sub 1 represents the x value of the first point. The x sub 2 represents the x value of the second point. That's the language you use in mathematics, so we don't have to write all that other stuff down. So point 1 is what location? It's at 1, 1. So therefore, that's x1, y1. Point 2 is at 5, 4, which is x2, y2. Whenever you deal with formulas that require input, always do 2 things. Label the information you have and then write down the formula. Don't ever start jumping in and writing stuff in the formula. That's where most mistakes happen. Because in this formula here, a lot of, okay, in our example here, we have, this is 1, 1. This is 5, 4. The biggest mistake I see students do is y2 minus y1. They'll go to the first point, 1, 1. They'll do that. It's just because they're in a hurry. So when you have this, the first thing you should do is label your values. Because once you do that, then it's a matter of plug and play. That's all mathematics really is. It's a matter of plug and play. Once you get to where you're supposed to be. Again, I ask students this in every semester pretty much, and I get the same answer. What part of math do you hate the most? Word problems. Some people say I hate division. When I say what about word problems, they say, oh, I hate that even more. Why? Because it's nothing more than reading just a small paragraph. You're used to that, but you're not used to learning how to read for specific information. That's what we have to do in mathematics. We have to look for specific information to use in our formulas. So what is x1? x1 is the x value of the first point. x2, y1 is the y value of the first point, and y2. So this is what we did yesterday. And then now we just plug and play. So we have 4 minus 1, 5 minus 1, 3 over 4. And that's your slope. And we define slope as what? As the relationship from each point on a graph, from one point to the next. Because what this one says, wherever my first point is, I go up 3, and then I go over 4. From every point. Because it's positive. If it's negative, I do what? I go down. The top is the only one that changes directions. The bottom always goes to the right. Think of it like time. You can never go back in time. So the bottom number always goes to the right. So what this is telling us is from our first point to get to the second point, I go up 3. Then I go over 4. And it's always, no matter which direction you go to, it'll be the same information. Now, with this, if you have a fraction that looks like this, change it to that. You never want to have the denominator to be negative. Or you could put it out in front. Can you guess why? Can you guess why we'll never want to have a negative on the bottom? What's the rule for subtracting fractions? You have to have a common denominator. So since this one's a 4, this one doesn't have a 4 on the bottom, I have to give it a 4. This one has a 5. This one doesn't have a 5 on the bottom. So why do I multiply by 5 over 5 here and a 4 over 4 here? Yes, but why top and bottom?
But it's one.
Why does that have to do anything?
It does not change anything.
Very good. 1 is called a unitary number. If I multiply anything times 1, what happens? It stays the same. So all I do is change the way it looks. I don't change the number. So 5 times 3 is 15. 5 times 4 is 20. Minus 4 times 4 is 16. 5 times 4 is 20. Once you have a common denominator, I put that. You notice there's neither a negative, nobody's a negative here. Once you have that, then the top number has the sign. What is 15 minus 16? If the signs are different, take the sign of the larger number. I'll write this down in a second as well. If the signs are different, take the sign of the larger number, which is negative. Then subtract the numbers. 16 minus 15 is 1. There you have number 2 problems in mathematics. The answers are mostly wrong, because of that little symbol. Negative, subtract. I've seen students do beautiful work all the way down. All of a sudden, at the very end, they put a negative in the answer. I asked them why. It didn't look right. It turned it from mathematics to an art fashion class. So no, it's just, it is what it is when you finish what you're doing. All right, so I'll write down the steps there on adding, subtracting signed numbers. Signed numbers. 1. If the signs are the same, then take the common sign and add the numbers. The signs are the same, take the common sign, add the numbers. 3 plus 5 is what? It's 8. What kind of 8? Positive or negative? Why? Because they're both positive. Negative 2 minus 9. They're both negative, so it's answer negative, and add the two numbers. As simple as that sounds, so many students are lost when they do that. Actually, because what I was going to do this morning is give you this. Get your blood pumping. We'll do this in a second. We'll go through all these. Just to get our brains working and think mathematically. 2. If the signs are different, take the sign of the larger number and subtract the smaller number from the larger number. When we do word problems, we're going to see that subtraction, one of the words that defines subtraction is the word difference. The difference, and that's why if it's different, we have a difference, therefore we subtract. 9 minus 3 is 6. 2 or negative 2 plus 5. Yeah, because the signs are different. Take the sign of the larger, which is positive, and subtract numbers. 5 minus 2 is 3. Negative 7. 15 is bigger than 8. It's negative, so the answer is negative. 15 minus 8 is 7. Negative 6 plus 3. 6 is bigger, so it's negative 6 minus 3. What I'm showing you here is to remove that large possibility of mistake. Treat the signs and the numbers separately. Treat the signs and the numbers separately. What I'm getting to is something like this. Let's say we had this. How would we solve this? Let's even forget this right now. How would we solve this equation? There you have another mistake. Well, it's not really a mistake, but it can lead to mistakes. Because if you go through and divide by negative, look at all these signs you have everywhere. You're going to leave off one. You're going to get confused of which ones it is. But think about how you write your notes and everything, and we do math problems. Students cram everything on a piece of paper. Don't. Use the entire paper if you need to for one question. I mean, don't try. You don't get any points for. Okay, here's question number 1. Here's question number 2, and you have 15 questions on one sheet. You get no bonus points for that. You get a headache because you're trying to write really small and everything. No, if you have to use multiple pieces of paper, because it's cheaper to buy more paper than repeat this course if you make mistakes. It's cheaper to do that. So if you make a mistake whenever you make a mistake and you're trying to check your answer again, do not do it on the same paper that you just did it on. Subconsciously, your mind is you're gonna look at peripherally what you just did and you're gonna repeat the same problem. If you made a mistake, take that paper, put it aside, or turn it over and try it again. And then compare the two things. But anyway, what I would do now, don't do that. Of course, you can do it if you want to, but chances are you'll make a huge mistake later on. When you have something like this, remember, treat the signs separately. I have to get rid of this negative, right? Just change the signs on both sides. I change this one from negative to positive. I change this one from positive to negative. It's the same relationship. Now I divide by 8. It's a lot cleaner that way. Now, if you want a mathematical reason why you can do that, negative 8x equals 3. If I take both sides and multiply them by negative 1, what is negative times negative? Positive. 1 times 8, positive times negative, 3 times 1. So I instead of doing all that mathematics stuff, I can just go ahead and just change this one and I change that sign. Treat your signs and your numbers separately. Of course, again, you had more years of doing it the way you've been taught and what you thought was right. But if that would have worked so well back then, what are you doing in this class? Now, I'm going to give you guys shortcuts and rules to help you so you minimize the number of mistakes you make. All right, so let's go to the next one. All right, so we just talked about slope. The next thing I want to talk about is distance. The distance between point 1 and point 2. So there we have a first question. What formula do we use for distance and why? Do we know any formula for distance? We do for moving objects, airplanes, boats, cars. We know the distance equals rate times time, if anybody took any physics courses. But that's not going to work here. That's for moving objects. But we do know this. If we took this graph and made a horizontal line through that one and a vertical line through this one, what have we just created? A right triangle. Do we know any formulas for right triangles? What formula? What formula do we know for right triangles? Pythagorean theorem. The Pythagorean theorem. I taught a education math class this first summer, and one of the students was doing a video on how you would teach this to students in your clear class. They said, it's Python. Think of a snake. No, it's not a python. It's Pythagorean. It's Pythagoras was a Greek mathematician who lived thousands of years ago. Lived on an island, actually, Samos. And he designed all these math ideas that we still use today. This is one of them. And I'll show you how he proved it. What he said, okay, we have this distance here and this distance here. What is the distance between 1 and 5? What's the formula for that distance? Yeah, it's 5 minus 1. That's how far they are apart. We did this last class. Likewise here, the distance here is the second number minus the first number. But remember, we're trying to get to a formula. So this is not really a formula. This is just application for it. So what we're looking at is if this is my first x and this is my second x, then the distance between here is x2 minus x1. It's the second point minus the first point. Likewise for this one, y2 minus y1. Have we seen this before? Yes. We've seen this before in the slope formula. Anybody remember what the Pythagorean theorem was? A squared plus b squared equals c squared. Where A and B are the legs of the triangle, and it has to be a 90-degree angle, a right triangle. Has to be 90 degrees. And C is the hypotenuse. That's the way the Greeks taught it. In America, we say A and B are the shortest sides, C is the longest side. So we know that the distance between here is 4, the distance here is 3. So A is 4, B is 3, and we're looking for C, the distance between 0.1 and 0.2. So we have C squared equals A squared plus B squared. A squared was 4 squared plus 3 squared, C squared. 4 squared is what? 4 squared means 4 times 4. It's, this thing tells you how many times you multiply this number here at the bottom is called the base. How many times you multiply the base together to itself? If it was a 5, it'd be 4 times 4 times 4 times 4 times 4, 5 times. So this is 16. 3 squared is 3 times 3 is 9. 16 plus 9 is c squared. What number times itself equals 25? 5. Okay, now we know that. But how do we prove this mathematically? What we do here, we have to get rid of the square. The opposite of square is the square root. So the square root and the square cancel out. That leaves c. The square root of 25 is 5. Why? Why is the square root of 25 5?
5 times 5 is 2.
Why? What would that be? Why?
It's 2 times 3.
No, because 8 is made up of 2 times 4. 4 is made up of 2 times 2. 8 is 2 times 2 times 2. This number here is called the root. The root tells you how many times that number has to appear to be taken out. Since that's a cube root, if I see the same number 3 times, I could take it outside from the inside. And now there's nothing left inside there. So that just disappears. So that's why it equals 2. That's how come the square root of 25 is made up of 5 times 5. This one has an invisible 2 there, which means I need 2 of a kind. Once I find 2 of a kind, I take it outside, and then whatever's left, there's nothing. So it's gone. Okay, there's also another thing that I just waved my hands over. If I gave you this, if I said c squared equals 4, what would you tell me the answer was? I would give you an eh. Negative 2 squared means negative 2 times negative 2. Negative times negative is 2 times 2 is 4. I know. Whenever the power is even and you get rid of it as a square root or a fourth root, what you have to do is put a plus or minus in front of the answer. So c can equal plus or minus 2. So whenever you square root something that's squared to get it by itself, you have to put a plus or minus in front of the answer. Because what that means, the answer could be 2 or negative 2. That's if it's even. How about this one? Why?
Because it's positive. Negative 2 times negative 2, it will be positive 4.
Negative, right. Because we know that 8 from earlier, 8 is made up of 2 times 2 times 2. Now they're all negative. Negative times negative is a positive. Positive times negative is negative. It stays that way. So if it's odd, the answer can be positive or negative. If it's even, the answer could only be even. Positive, I mean, can be odd, negative. So this answer, what would C equal? How would you get rid of that 3 right here? Take the cube root. Whatever is up here, I take that root. This thing tells me I need 3. So this and this cancel. I need 3 of a kind. Check. So the answer is -2. You what? You're right. We have to get rid of the square, so we square root both sides. Because it's square, I have to put a plus or minus in front of it. So give me 2 numbers that multiply to give you -4. Can't be done. We're going to spend a whole topic on this later on, chapter 3. This is called imaginary numbers. So for right now, can't be done. For right now. Because they have a whole field of numbers set up to them. You should be writing stuff down. Trying to work this out. Again, it's a square, so what do we have to do? Square root both sides. Because it's an even and I square root it, I have to put a plus or minus in front of it. 8, again, we know is made up of 2 times 2 times 2. It's a square root. So what number is in front of here? What's the root? So it tells me I need 2 of a kind. Here's 2 of a kind. I can put that number out in front. What am I left with? A 2 inside there. So that's what your answer equals. Now, what Pythagoras did, he didn't prove it this way. Remember, they didn't have half the stuff before. What he did, he noticed the pattern. Let's say this length here was 4, this length here was 3, and he didn't know what that one was. So he took these and he made a box. 4 blocks this way. So 4 blocks this way, 4 blocks this way is how many blocks? Yeah, it's 4 times 4. There are 16 blocks in there. Then he did the same thing on this side. And these are all the same size blocks. So this is 3 this way, so it's 3 times 3 is, and he did the same over here. He put the same blocks. And sure enough, he was amazed that he found that it took 5 blocks, which is, there are 25 blocks in there. So this was 5. Because of this, this is how he figured out. If I had 3 on this side, this is 3 times 3, so it's 3 squared. I have 4 here, so that's 4 squared. And this is 5 times 5, this is 5 squared. If I take this plus this, I get this. So that's what he figured out. That it always works. No matter what numbers you put inside there, that's always going to work. And then that's we realized that these shorter sides, this hypotenuse is actually the distance from point A to point B. It's a distance. So instead of using C, we can go D squared is X squared plus Y squared. Horizontal and vertical. Remember, it's the distance. What's the formula for distance for this horizontal length? X2 minus X1 squared, that's what X is, plus Y2 minus Y1 squared, that's that one, equals the distance squared. We're not done yet. We have to get distance by itself. So we have to square root both sides. Now let's clean this up. The square root and the square cancel, so we just have D. Let's look at this part. Can you have a negative distance? No, there is no such thing of a negative distance. Whether you walk forward, backwards, to the side, you're still going a distance. So this is always going to be positive. X2 minus X1 squared plus Y2 minus Y1 squared. And there's our formula for distance. Again, it's plug and play. It's formula driven. In our example, remember, we labeled X1, X2, Y1, Y2. X1 and X2, X1 was 1, what's X2? 5. Y1 was 1, Y2 is 4. Look back on your notes to that. We can either plug these this way, or we can look at our formula for slope. Remember our formula for slope? Y2 minus Y1, X2 minus X1. That's exactly the same formula we have here. So in our slope, we had 3 over 4. So the Y2 minus Y1 the Y2 minus Y1 I know is 3. X2 minus X1 I know is 4. Or you can go ahead and plug them in there if you want. But the beautiful thing about this is once you do this X2 minus X1, Y2, you can just record those and start plugging them in out of these formulas. So the distance between those 2 points, 4 squared is 16. 3 squared is 9. 16 plus 9 is 25. And the square root of 25 is 5. So that's my distance between 0.1 and 0.2. Pretty easy. It's just plug and play. And that's what I tell you. Whenever you do these problems, always start off, if it asks you for distance, write down this formula before you plug anything in, because it's going to help you memorize it. Don't just jump into this, or there's no plugging numbers. Start write down the formula first, and then start plugging stuff in next line down. All right, so that's the distance and the slope. Let's look at the third one we're going to talk about. The midpoint. What exactly is a midpoint? How would you define midpoint?
Middle point.
No, you can't say middle point. That's
That's not what.
yeah. Very good. The point halfway between the endpoints. Point 1 and point 2. That definition also should give away the formula. So what is the point? What is something halfway between? How would you find something halfway between two numbers? Do what first? Add them. Because if you think about it, what if you're talking about like grades? If you took two tests and you made an 80 on one test and 100 on another test, what's your average? Yeah, 80 and 100. So you add those together, you get 180. There's only two tests, so you divide by 2, let's go 90. That number is halfway between the two numbers, which is what the average is all about. So remember, it's a point. A point means what? It has to have an X and a Y component. Has to be an ordered point, an ordered pair, because it's a point. Now let's look at this. For the midpoint, we use the capital M instead of the little m. So the capital M, it's a point. So how do you find the average of two things? Add them together and divide by 2. So in this one, here's our first one. This is x1, this is x2. So I can put those in there. 1 and 5. 1 plus 5 over 2. This is my first point, and this is my second point for the y values. So it's 1 plus 4 over 2. As we can see, the number between 1 and 3 is what? Or 1 and 5 is 3. The number between 1 and 4 is 2.5. So there is your midpoint. 1 plus 5 is 6 over 2. 1 plus 4 is 5 over 2. 6 over 2 is 3. 5 over 2, I can leave it as 5 over 2. Or I can make it 2.5 or 2.5. Because it's a location. It's not important. It's not as important as it is slope, how you write the slope. But I can't tell you that the computer would accept this kind of answer. It makes it much easier for the computer, even though it's an improper fraction. So think what we've talked about so far. We've talked about the slope, the distance, and the midpoint. Little m, capital M, and D. What other formulas do we need to know? Well, for right now, well, we're going to get to the point of talking about equations of lines. We have a lot of stuff to do before that. Don't sit in the back anymore. So let's talk about certain types of points of graphs. So here's your line. And we'll get to that point of defining the line later on. There are 3 different types of lines that we can have. One, we can have a horizontal line. What does horizontal mean? Yeah, it goes left and right. We can have a vertical line that goes up and down only. Then we have all other lines. They can either go up or they can go down. If you notice, if we have our Cartesian coordinate graph, the x-axis is called what? Actually, the horizontal axis is called the what? X-axis. And the vertical is the y-axis. So these 3 different lines, if it's horizontal, it only crosses the y-axis at some point y. If it's vertical, it only crosses the x-axis at some point x. If it's anything else, it will cross both the x and the y-axis. Make sense? These are called intercepts, where these graphs where the graph crosses the X and or Y axis. So for my horizontal line, what intercept do we have? X or Y? We have a Y intercept. What's the location? Because remember, since it's an intercept, it's a point. It's a point. Since it's a point, it has to have an X and Y component. So in this one, the horizontal line, it's 0, 3. Because it crosses at 3. What about the vertical line? It only has an X intercept. So what is its location? 4, 0. Let's think about this. Vertical lines can only go up and down. It can only cross the x-axis. Or it can become the y-axis. Isn't the y-axis a vertical line also? So a vertical line can cross anywhere on the x-axis. If it's a vertical line, it crosses at x equals 0. Same with the horizontal line. And other lines will have both an x-intercept and a y-intercept. So what's the x-intercept on this example? -2, 0. And then the y-intercept is, remember, you can't just say -2. -2 is not an intercept. -2 is a number. The x-intercept is -2, 0. That's the location where the graph crosses the x-axis. The y-intercept is at 0, 1. That's where it crosses. So far, so good? Pretty easy so far. Now, the beautiful thing about horizontal and vertical lines, you can tell me the equation of those lines. If it's a horizontal line, will it ever cross the x-axis? No. So the equation was always going to be that. Because no matter what x you give me, y is always going to equal 3. Now with the vertical line, no matter what y you give me, x is always going to equal 4. This is the equation of the line for these two guys. So the equation of the line for a horizontal line is simply the y value. The equation of the line for a vertical line is simply the x value. That's what it's telling us. So far, so good. But we're getting to a point to discuss actual equations of lines. How are points and equations of lines related? How are points and equations of lines related? If a point is on the line, then when you plug the x and y values of the point into the equation of the line, the result is equal. Yes.
I've been here yesterday, so we're doing that.
I'll send them to y'all. Yeah. Because the Xerox isn't working, so I have to go do that at home. I'll send you at the end of today. I'll send you the notes from yesterday and the videos from yesterday. Yeah, so pretty much I'll try to do that at the end of each day. You guys will get a whole bunch of them. So, and I'm also going to put it online as well. You'll have where it says the videos and everything. You'll have the current semester's videos, and it's always going to populate it. So, for example, here's your equation: 2x plus 3y equals 18. Tell me if these points are on that line. Are the points on the line? So we have this equation. Plug them in. This is my x and this is my y. 2 times -5, 3 times 7 equals 18. Positive times negative is negative. 2 times 5 is 10. Positive is a positive. 3 times 7 is 21. They're opposite signs. So I take the sign of the larger, it's positive, and subtract. 21 minus 10 is. Does 11 equal 18? No. So -5, 7 is not a point on the line. Do the same thing with the other one. 2x plus 3y equals 18. X is 3. 2 times 3 plus 3 times 4 equals 18. 2 times 3 is 6. 3 times 4 is 12. 6 plus 12 is 18. Yes. The point 3, 4 is on the line. So what do we call that? If we say it's on the line, we're talking about a solution. in this case. And because it's the way the question is asking. Now, in the rest of the course, whenever we talk about the word solution, there are other words that we use in its place. We will talk about x-intercepts, roots, factors, and zeros. All of those words mean the same thing in mathematics. When I ask you for a solution, I'm looking for the x-intercept. If I'm looking for the zero, I'm looking for the x-intercept. Or it can be called a solution as well. So all of these words mean the same thing in this course. It's just different ways I can ask for it. So far, so good. All right. Let's try to find x and y intercepts. Find the x and y intercepts. Two x plus 3y equals 18. There's the first one. Here are the steps to find the x and y intercepts. To find the x-intercept, remember, where exactly is the x-intercept located? Is that? On the horizontal line. So it's where it crosses the horizontal line. What's the y value of the x-intercept? So your first set is set y equal to 0. The x-intercept is where the line crosses the x-axis. There is no y value. Then the second step is solve for x. All right, so in our example, we have 2x plus 3y equals 18. I want the x-intercept. So I set y equals 0. What is 3 times 0? 0, so it disappears. Then to solve for x, I do what? It's whenever you solve for something, it's always the opposite of what's there. How is 2 connected to x? What operation? Multiplication. So what's the opposite of multiplication? Division. So I divide both sides by 2. 18 divided by 2 is 9. So my x-intercept is at 9, 0. And let's do the y-intercept now. The steps for the y-intercept since we're looking for the y-axis, I don't want any x's. So I set x equal to 0. Get rid of the x's. and then solve for y. So put x is equal to 0. 2 times 0 is 0, so that's gone. So I have 3y equals 18. Divide both sides by 3. So my y-intercept is at 0, 6. The beautiful thing about this is if we have x and y intercepts, we can graph the equation. Because we know the 2 points. We know the point is 9, 0 and 0, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9, 0. 1, 2, 3, 4, 5, 6. Those are my 2 points. Connect the dots. And there's my graph of my equation. Since these are lines, how do we know they're lines? How do we know this is an equation of a line? Because at the beginning, that's at the end of this this first chapter, we're going to go through what's called a library of functions. There are 12 of them. The ones that start off and build the rest of the equations in mathematics. We know this is a linear equation because x and y don't have any exponents, any powers. They don't have any special symbols, any signs. They're just x and y. That's why we know it's linear. All right, let's do another example. Example 4, same thing. Here's our equation. 3x minus 5y equals -10. So the first thing we're going to look for is the x-intercept. And then we'll do the same thing for the y-intercept. So to find my x-intercept, what I got to do? Set y equal to 0. So that's gone. So that's my x-intercept. The location of it is at -10^3, 0. That's the x-intercept. Can you graph that? It would be very horrible because you don't know exactly where -10^3 be -3 1/3 again. It wouldn't be accurate, so we wouldn't graph that one. For the y-intercept, what do we do there? Set x equal to 0. Three times 0 is 0. It's gone. We're trying to get to y. We have to get rid of the negative, so just change the signs. And divide by 5. We can plot that one. So to graph this equation right now with what we know, we can't really graph it that well. It would be a guesstimation. But we can use this point. We can use that point, and if we can find the slope of that equation, then we could follow the slope from that point. Remember, the slope is what? It's the relationship from one point to the next. So we can start off at this point and follow the slope. Like if it was up 3 over 4 from that, up 3 over 4. So that's how we graph it. But not yet. Example 5. Y equals x squared minus 9x minus 12. We won't bother finding the x-intercept here because I don't agree with what the author did here. You see, it has an exponent. Is that a linear equation? No, it's a quadratic equation, meaning the graph of this one will look something like this, which means we can have two x-intercepts, or we can have one x-intercept, or we can have no x-intercepts. That is chapter 3. Why they threw it in the first section of chapter 1, I don't know. But we can find the y-intercept. No matter what kind of equation you have, if it's not linear, the y-intercept is always the constant term. What I mean by constant term does not have an X. It's like a cowboy song. They don't have an X. So in this example, what's my y-intercept? Negative 12. It's the only thing that doesn't have an X. So my y-intercept is at the point 0, negative 12. Yeah, we'll talk about those kind of equations a lot in the very near future. Everybody okay so far? Okay, let's look at some more examples of what we've been doing. Example 6. Find the distance between negative 2, 2 and 3, negative 6. What's your first step always when you solve a problem? Write the formula down and label what you have. So what's the formula for distance? X1 plus X2 is midpoint. So the distance, just think about how it relates to the slope. Because we use the entire line for a slope equation and for distance equation. Midpoint, we only use half of it, so that's why it's a different formula. Always start off with what you know. You know the formula, hopefully. You know what you need. So X1 is what? That's X1. This is Y1. This is X2. Y2. Y2, X2 is 3. Y1 is 2. And Y2 is -6. Anything difficult yet? Nope. If memorizing something is difficult, then we got issues. The formula is itself. It's constant. It's never going to change. Same formula. So we plug and play. X2 is 3 minus a -2. Y2 is -6 minus 2. Whenever you substitute something after a minus sign, you put that number in parentheses. Because that minus sign is not the same as that minus sign. So I simplify. I got two negatives next to each other. Negative times negative is a positive, so it becomes a plus. -6 minus 2. Three plus 2 is 5. Where? -6 minus 2, they're both negative, so the answer is negative. So we add 6 plus 2 is 8. Five squared is 25. -8 squared is, you should have your cheat sheet, your multiplication sheets in front of you. Should be 64. That's why I gave you the little multiplication sheets. 2, 4, 6, 8. I should have had enough in there. Did we run out? So don't take any extras. Take one each. That's all you need. So 25 plus 64 is 89. Now, can we go any further with 89? What is 89 made up of? Is it divisible by 2? How do we know it's not divisible by 2? It doesn't end in a 0 or an even number. How do we know it's not divisible by 3? If it's divisible by 3, let's say the number is 251. How do I know that number is divisible by 3? If I take all these digits and add them together, what do I get? Is 8 divisible by 3? No. If this number is not divisible by 3, then this number is not divisible by 3. So 8 plus 9 is 17, not divisible by 3. Is it divisible by 4? To be divisible by 4, is it divisible by 2 twice? No. Is it divisible by 5? Is the last number 0 or 5? No. Is it divisible by 6? Divisible by both 2 and 3? No. By 7? No. 8? No. Same reasons, all those. So it's the prime number. This is our answer. So the distance is, so in other words, what I'm getting to is if you can simplify. So there's the distance between point A and point B. Example 7. The point -2, 5. Again, you don't have to write all this stuff down. You have it in the packets I gave you. This is example 7 in your packet. The point -2, 5 is on a circle. That has 3, -1 as its center. Find the length of the radius of the circle. All right. Always helpful to draw a picture. So the center is at 3, -1. There's a point at -2, 5. It's asking us find the length of the radius of the circle. This is where you have to know words in mathematics. And when we deal with circles, we have radius versus diameter. What's the difference? What's a radius? What's a diameter? Very good. It's the radius. Radius is half the diameter. So or the diameter is twice the radius. Here's the center. The radius is a spoke of a bicycle tire. The diameter is how wide your tire is. So if you ever go buy an inner tube for your bicycle, you have to know what the diameter is. So what we're looking for is the radius. We're looking for this here. It's the length. What's another word for length? Distance. In this context, is distance. So this is a distance problem. X2 minus x1 squared plus y2 minus y1 squared. We just plug in the values. Well, if we label them first, x1, x2, y1, y2. So what is x1? -2. x2, 3. y1 and y2. That's the hard part. That's where, if you're gonna make a mistake, that's what's gonna happen. You have to be very, very, very careful. X1, Y1, X2, Y2. Make sure you label them correctly. Because if you get this wrong, doesn't matter how good you are with this, it's gonna be wrong. So X2 is 3 minus -2 squared. Y2 is -1 minus 5 squared. So negative and negative becomes a positive. So we have 3 plus 2 is 5. -1, -5, they're both negative. So I add them. I get -6. 5 squared is 25. 6 squared is 36. So 25 plus 36 is 61. Pretty straightforward. It's just plug and play, like I said. All right, let's look at example 8. Find the midpoint of the line whose endpoints are -4, -2, and 2, 5. So find M, capital M. That's a symbol for midpoint of the line whose endpoints are these guys. So what's the formula for midpoint? Yeah, this is the average, x1 plus x2 over 2, y1 plus y2. So this is x1, y1, x2, y2. So we have -4 plus 2 over 2, -2 plus 5 over 2. Negative and positive, they're both opposite signs. Take the sign of the larger. 4 minus 2 is 2. Same thing here. This time it's positive. 5 minus 2 is 3. So the midpoint is at the location -1, 3/2. All right. Let's go to example number 9 in your packet. The diameter of a circle connects the points 2, -3, and 6, 4. On the circle. Find the center of the circle. Again, draw your picture. We have 2 points that are on the circle. 2, -3, 6, 4. It's the diameter, so it goes all the way across. What do we know about the diameter of a circle? And how does it relate to the center? with, I would say, I didn't say radius, I said, what is it, how does it relate to the center? Right, the midpoint of the diameter line has to go through the center of the circle. Diameters have to go through the center of the circle. If it doesn't go through the center of the circle, then it's a secant line. If it doesn't go through the center, then that line is a secant line. If it goes through the center, then that'll give us the diameter. So since this is the center is actually what? The center is the midpoint of the diameter. So we have x1 plus x2, y1 plus y2 over 2. Again, label your points. This is x1, y1, x2, y2. So 2, 6, negative 3, 4. Two plus 6 over 2, negative 3 plus 4 over 2. Eight over 2, 1 over 2. So there's the midpoint, which also tells us it's the center of the circle. Again, so it's very important to know how all these terms relate to each other. Because that's all the questions. The questions are going to ask you something. You have to decipher what it's telling you. That's what I told you. In mathematics, when you read something in mathematics, you have to read for specific content, information, not just what is it, what are the numbers, that's it. All right, so now let's move on. Let's talk about circles. What is a circle? And don't give me that wedding thing. It's something that never doesn't have a beginning, doesn't have an end. No. What is a circle? A circle is an infinite number of points that are all equidistant from a central point, central location. It's an infinite number of points that are all equidistant from a central point. So we have a center point. We call it the C. let me make this on a XY graph. Actually, for this first one, I'll make it easier for you. I'll even put the center at the center. So here's the center, and I know the points are 3 units away. So that one's 3 units away. That means the next one over here has to be 3 units away. This one here has to be 3 units away. That one there has to be 3 units away. That's not too impressive. Now, these points here have to be 3 units away. This point here has to be 3 units away. Okay, so that's what it's telling us. But how do we get to an equation of this? We have x's and y's here. This first line here, if we drew a line straight down, what have we just created? A right triangle. This point here, if we drew a line straight down, we just created a right triangle. This one here, same thing there. And this one here. So each one of these, no matter what point I pick, I can create a right triangle. So you see what's happening is more and more of these points that I have, and I start connecting them. I shouldn't even connect them because they'll all get closer to each other. So how do we define the equation of the circle? Well, we know that it's Pythagorean theorem. The A is the horizontal axis, so it's x2 minus x1 squared, y2 minus y1 squared equals, now instead of this hypotenuse, the c value, it's now the radius. So we have the radius squared equals x2 minus x1 squared plus y2 minus y1 squared. But there's a difference here between the right triangle that we've talked about and the unit equation of a circle. When we talk about a circle, we have the center point. Does it ever move? No. It stays the same. So the center is our x1, y1 point. The center is the beginning point. All points on a circle begin from the center. Well, instead of using x1, y1, we use h and k. So the equation of a circle, x minus h squared plus y minus k squared. There's your formula for a circle, which we've just defined something that has no corners, no edges, no points, from something that has 3 edges, 3 points. It's a triangle. So if I give you this, what would the center and my radius be? If I gave you this, very good. The center would be 5, -2, because it's inside the parentheses, and the answer is always opposite of what's inside the parentheses. So that's where H and K are. That's my center. What's my radius? Y3, not 9. Isn't 3 squared 9?
But we're just taking the R, not the.
Right, because R, in this formula, R is squared. So this number is squared. Very good, very good. What if I gave you this? What's my center and what's my radius? Yeah, since this one doesn't have anything plus or minus, it's 0. And this is -3, so the answer is +3. That's my center. The radius is what? Square root of 5. Because the formula says R squared equals this. So if R squared equals 5, then R is equal to the square root of 5. Another way I can give you that formula is if I had it in square root. But we have 2 more examples, then we'll call it a day because well, I don't know, we'll look at it. Example 10. Find the equation of the circle with radius 5 and center 3, -7. Again, we're looking for the equation of a circle. So we start off with our formula. R squared equals x minus h squared plus y minus k squared. Plug and play. Radius is 5. So that goes in place of r. So it's 5 squared. X minus, this is h. Y minus k. This is k. So it's -7. 5 squared is 25. X minus 3 squared. That becomes a plus. Y plus 7 squared. That's all there is to that. Any questions? All right, so that's the end of the first section.